Good afternoon, Dr. Key and everybody. I am Jamal Faraj Abdelhamid Aliwa. Today we're gonna compare two Imidazoline-based corrosion inhibitor, both tested in 1-MHCl, to understand how laboratory performance translates into field engineering decision. The two cases are Zhang et al. In 2011 with Imidazoline phosphate and Sajao et al. In 2025 with two new Imidazoline derivatives. We will cover acid corrosion background, case 5, the external case, comparative analysis, engineering inside the decision matrix, monitoring, and conclusion. In industrial HCl application, pickling, oil well acidizing, chemical cleaning, the problem is rapid steel dissolution, where iron plus 2 hydrogen ions gives ferrous ions plus hydrogen gas. Inhibited corrosion rate reached from 7 to 10 millimeters per year, operationally unacceptable. That's why from engineering perspective, chemicals inhibition is most economical and practical solution, not upgrading the material, of course. Inhibitor adsorb into metal surface from 1 to 10 nanometer, thicker barrier to adsorb types, physioabsorption, electrostatic or van der Waals bonding. It is versatile with delta G adsorb between 20 to 40 kg per mole. Chemoabsorption, covalent or coordinate bonding. It is irreversible with delta G adds below 40 kg per mole. E molecules feature heteroatoms like N, O, S, P donate electrons to iron atomic ring provided, and B electronic code and hydrocarbon hydrophobic tail replies water. Zhang et al. Synthetic new Imidazoline phosphate inhibitor, environment 1-MHCl at 25 centigrade, metal Q235 mild steel, optimal concentration 200 milligram per liter, method weight loss, potentiodynamic polarization, EIS, electrochemical impedance spectrography, and quantum chemistry using PMS semi-empirical method. The molecules has in Imidazoline ring 2 nitrogen atoms, phosphate group P and O, and hydrophobic tail. DFT density functional theory calculation show N and O atoms carry negative charge. They donate electrons to the iron surface. P atoms is positively charged. It accepts electrons back from iron. This multi-site adsorption explains the high efficiency. Important engineering limitation, only 25 centigrade static condition, no high temperature date, no flow or shear effect. This means direct field application has not yet justification without further testing. Without inhibitor, uniform corrosion, vigorous hydrogen bubbling, corrosion rate 7.55 mm per year with 200 milligram liter inhibitor rate drops 2.177 millimeter per year. That is 97.7% inhibition efficiency. The inhibitor blocks both anodic iron dissolution and cathodic hydrogen evolution reactions, so it's a mixed type inhibitor. Key parameters E-core, which is corrosion potential, shift only 6 millivolts, less than 85 millimoles. Confirm mixed type inhibitor. I-core corrosion current density drops from 1185 to 1.9 microampere per square centimeter, 9900% reduction. Tafel slope beta A and beta C barely change. That means geometric blocking mechanism. The inhibitor covers the surface but does not alter the reaction pathway. Newcast plot show a single capacitive lobe charge transfer controlled. RCT charge transfer resistance increased from 50 to 850 ohms centimeter square, 17 times higher, meaning much better protection, double layer capacitance, dropped by 90% from 500 to 52 microfarads per square centimeter. This indicates that water molecules are displaced by inhibitor film. Engineering conclusion: corrosion shift from active dissolution to charge transfers controlled process. Newcastle, the Lungerium asymptotic fits perfectly. R squared equal 0.999. Adsorption equivalent constant equal 2 multiplied by 10 square 4. L per motor strong efficient. Delta G equal 34.5 kilogram mole. This falls between 20 and 40, so it's mixed physous absorption and chemoabsorption that explain high efficiency and reasonable stability under moderate condition. PM6 calculation confirm negative charge on N and O atoms. They donate electrons to ions. The positive charge on P accept electrons back from ions. The molecular levels validation strengthens the electrochemical results. Application include acid pickling tanks, oil well acidizing equipment, and chemical cleaning vessel. Type typical HCl pickling 1 to 5 m, 25 to 60 degrees centigrade carbon steel with inhibitor protection. Temperature was not studied. Higher temperature typically reduces absorption flow. Not study, it may affect absorption kinetic. Only one MHCl is tested. Higher acidity may compute for absorption sites. Strength 97.7 efficiency mixed type. Lingmar absorption. Quantum validation. Cost effectiveness 200 milligram liters. Limitation lab scale only. No temperature study, static system, no scanning electrons microscopy, and phosphate may hydrolyze over time. From engineering perspective, this inhibitor is not yet field qualified. Saj Otau 2025 synthesized to imidazolidine derivative. IMID BR contains bromine. IMID CH contains an alkaline groups. CH environment 1 MHCl, same as case 5, but the temperature range 25 to 55. There's advanced characterization in MR, nuclear magnetic resistance, and for our transformer rate, high resolution mass spectrometry. IMID bar has bromethyl groups. IMID-CH has propyl groups. Both were fully characterized. No degradation product detected. At 10 to the third power moles, approximately 300 milligram per liter. IMID PR gives 94.6 inhibition. IMID-CH gives 89.8.2 percentage. I-core is reduced 18.7 times for IMID, 9.2 times for IMID-CH. Both are mixed type inhibition. Delta E core less than 85 MV. The bromine atoms enhanced electrons acceptance. IMID PR increased RCT from 35.8 to 671.7 ohm centimeter square, 19 times the blank CDL. Decreases from 121 to 53.8 microfarads per square centimeter. A thicker, denser film, single capacitive lobe charge transform control. Activation energy EA, the energy barrier for corrosion, blank 21 kg per mole, low barriers, fast corrosion with IMD CH 32.8 kg per mole, with IMD BR 45.3 kg per mole, the highest barriers. Delta G adsar for both is below 40 kg per mole. The indicating chemoabsorption, the apparent construction higher EA suggests vasosorption, but very negative delta G at ADS suggests chemoabsorption actually means mixed absorption. The IMID by PR has the best high temperature performance. CIM scanning electron microscopy image at 500x magnification, blank severe pitting, wide corrosion product, heavily damaged surface, IMDBR, smooth uniform surface, no pitting, no holes, MDCH better than blank, but some surface feature remain. This is direct physical confirmation of film integrity, critical of failed credibility. CM scanning electrons microscopy images at 500x magnification, blank severe pitting, white corrosion, products heavily damaged surface, IMD-EBR smooth, uniform surface, no pitting, no holes, IMDCH better than blank, but some surface feature remains. This direct physical confirmation of film integrity, critical for failed. Strength 94.8 IE work up to 55 centigrade. Same confirmed TFT plus molecular dynamic, full characterization limitation lower EI than case 5, higher concentration 300 versus 200 milligram per liter, bromine toxicity concern, lab scale. This is a key engineering conclusion, case 5, higher efficiency 97.7, but limited to 25 centigrade. IMIDBR slightly lower efficiency 94.8, but thermally stable up to 55 centigrade. E8 45.2 kg per mole. Efficiency alone is not sufficient for high temperature application, thermal stability, governing performance. No universal inhibitor cost efficiency, case 5 lower dosage, high temperature, bigger than 40 degrees centigrade, IMID, PR environment, safety, case 5 no bromine, room temperature, pickling, case 5, D-ball acidizing, 50 to 90 degrees centigrade, IMID, PR, or Athoria modified analog. Selection is application specific. Both studies used identical 1M HCl static condition and atmospheric pressure. The key difference, case 5 only at 25 without no surface analysis. The external case tested up to 55 centigrade and provided is CAM plus DFT molecular dynamic that makes the external case more relevant for elevated temperature acidizing. Both inhibitor work via mixed absorption, however, the external case show more negative delta G at ADS minus 52 to 53 kg per mole and proven temperature robustance. The bromine atoms in IMIDBR act as an additional improving film stability at higher temperature. A summary, highest IE case 5, best temperature robustness, external case IMID, PR, best validation external case CIM plus DFT plus MD, environmental case 5, selection balance, performance, stability, and applicability. Corrosion control is incompatible without monitoring for an HCl pickling tank inhibitor residual 200 plus minus 20 milligram per liter by UV-VS spectroscopy, corrosion rate below 0.2 millimeter per year using an LBR linearization resistance probe or weight loss coupon, temperature 25 to 30 centigrade for any failed system, monitor iron count, dissolved oxygen and bacterial activity monitoring, enable early detection and system. 3 conclusion, Imidazoline inhibitor achieve 94% efficiency and cell system through mixed absorption. Selection must be governed by temperature, stability, environmental constraints, and operational conditions, not by efficiency alone. No universal inhibitor exists. Optimal selection is application specified balancing, cost, thermostability, and environmental safety. Corrosion inhibition is not chemical choice, it's an engineering system decision. Thank you for your attention. References are listed below. Thank you.